Now it's time for one of the famous river questions. So we have a boat in this picture here, and it needs to cross straight across the river, except the river is flowing downstream at 4 meters per second. So if the boat aims straight across, then the river will actually push it downstream and the boat will head off that way, which is not what we want. So what has to happen is the boat has to aim upstream, and it has to aim upstream in such a manner that when the river pushes it downstream, that the result is it ends up going straight. So if you actually see it from above, it almost looks like the boat's traveling sideways but in a straight line so that it can land at the dock here on the other side. So we must find the angle that it needs to aim the boat at so that it can land straight across. So we're looking for this angle here. So if I redraw this a little bigger so we can see a little better. So the boat can travel at 9 meters per second in still water. So that's the fastest that the boat can travel. So if there's no river, it's traveling at 9 meters per second. If the boat aims perpendicular to the river, it still travels at 9 meters per second in this direction. However, with the river flowing at 4 meters per second, it will actually end up going faster. And so we add those head to tail, and it actually ends up traveling at 9.87 meters per second at this angle here. But again, this is not what we want. We need to land straight across. So it must take its 9 meters per second and aim this way, so that when the river pushes it downstream at 4 meters per second, the result is that it ends up going straight. In order to find out the time it takes to cross, we need to know the speed that it travels in this direction, and in order to get that, we may also need the angle. We're going to wait and see on that. Turns out this is actually a right triangle. And since it is a right triangle, and I have two sides, I actually don't need an angle. We're going to go over the angle just so you can see how you would do it. But you actually don't need an angle to find out Vy. To find out the angle, my angle theta here, then I have opposite, and I have hypotenuse, and that's equal to sine theta. So to find out my angle, theta is going to be inverse sine of opposite 4 over 9. So the angle (26.4 degrees). So this boat has to aim at 26.4 degrees upstream into the water, into the river, so that it can go straight across. Now, part of its velocity is going to be fighting against the river, fighting so it doesn't move downstream, and part of the velocity helps it move in this direction, and that will be Vy. So in order to find Vy, in this case we're going to use Pythagorean theorem. We're going to say c squared is equal to a squared plus b squared. So our hypotenuse is 9, so 9 squared is equal to 4 squared plus, we're going to say it's our vertical speed squared. And so when we work it out, our vertical speed is 8.06 meters per second. That's the speed with which it can cross the river. To find time, time will be distance divided by velocity. Now the distance it travels is 1200 meters, and it's traveling at 8.06 meters per second, and I can check my units to see if this works out. And this is going to leave me with seconds, which is perfect. If I take 1200 divided by 8.06. That is 149 seconds to cross the river. Now if we change this question up a little bit, we say if the boat aimed straight across, how far downstream will it land? So if instead our boat went straight across, how far downstream will it land from the dock? So to do this, we know the speed going across, Vy, and that is the maximum speed of the boat. It's going at 9 meters per second. I know the distance across the river, Vy, is 1,200 meters. So if the boat is going straight across, there's nothing slowing it in a vertical direction. The river is actually pushing it downstream, but it doesn't slow it down going in the vertical direction. So to find the time it takes to go across, we'll take our vertical distance divided by vertical speed, and we'll say 1,200 meters divided by 9 meters per second. So the time it takes to cross the river is 133.3 seconds. Now this whole time that it spends in the river crossing, getting to the side, the river is also pushing it downstream. So for every second it spends there, the river keeps pushing it down at 4 meters per second. So if the boat spends 133 seconds in the river is pushing it downstream at 4 meters per second that entire time. So to find the distance downstream, horizontal distance, I take the horizontal speed, which is the speed of the river, times the time that it spends in the river. So that is the horizontal speed of 4 meters per second times 133.3 seconds. And that works out to 533 meters. So the boat will land 533 meters downstream.